Okay, this is the first in a series of videos that I'm going to do to try to show you some basic principles that deal with intersecting lines and circles when the two are kind of combined together. And for example, this one has two kind of random lines that cross inside a circle, but you notice they don't cross in the middle. It's not like they cross right at the center of it. So not one of these lines is not the radius or the diameter. They just kind of randomly cross somewhere in the circle. Now, if you see what's being asked here, find this angle between those lines. Now, it doesn't really matter if I was asked for this angle here or this one here, because we know they're vertical angles, which means they're opposite each other. They're going to be the exact same amount regardless. So it doesn't matter which one I'm asked for or where the x is. It's the same thing on both sides. Now, there's a theorem that basically states this. If you get two lines that happen to cross inside a circle, what you can really focus on is the arcs that they intercept. And in English, that just means, what's this little curved piece of the circle that it sort of cuts off, like a little pie piece there. In this case, it says that that arc is 40 degrees. Okay. Now, if I look at the other side, notice, depending on where they crossed in the circle, this side looks a lot bigger. I've got a bigger arc here, a bigger chunk of the circle. That one's 120 degrees. Now, there's a theorem that basically figures out, this time it works every single time when you do this. If I were to take this arc and this arc, and I add them together, so 120 plus 40, I get 160 degrees total. So we have to add them together, both ends, the small end and the big end. If I take that and divide by 2, it's always going to give me this right here. It's going to give me, oops, it looks like a 6, there we go. It's going to give me the angle that happens to be, whether it's this side or this side, the angle between those lines that happen to cut through the circle. So occasionally this could be useful, especially when you have a circle where it looks like things are just sort of shifted over and we don't have lines that cross in the middle, like these, where they kind of cross on one edge of the circle, but not right in the center. So that's one theorem you can use, but you have to watch for it. You have to recognize, when do I have two lines that happen to cross inside the circle? Now, it doesn't always have to look like this one. Keep in mind, it could be something where I have a line that looks like this that does happen to go through the diameter, but then I get something like that way over there. Well, what I can look at if I get a situation like that is, well, if I'm trying to find, for example, and I know it looks like 90 degrees, but we don't know for sure. Let's say I'm trying to find that angle right there. Well, what I would look at then would be this arc right here, the big arc that those lines intercept, and then the little one on the other side. And I'd add them up and divide by 2. Okay? So sometimes there's a lot of applications for this particular theorem, and in the book you're going to see it maybe stated a different way, but this is the functional, practical end of it.